Question number 23, it says if the first and the nth term of the JP, the question says if the first and nth term of a GP are A and B. Now, and if P is the product of n terms. Now, then show that P square equals to AB raised to the power n. Now see the solution. In this question, what we have, if the first term and the nth term, so we can say, and this is a GP, geometric progression. So we can write let A be the first term. Now, and let's say the common ratio BR. Fine?
Yes.
Now they are saying the first term and the nth term. So first term is A, so they have given A as the first term. And the nth term is B, so we can say AN equals to B, right?
Yes.
And the formula for the nth term is AR n minus 1 equals to B. Is it okay?
Yes, sir.
Now they're saying the P is the product of the n terms. So that basically means P equals to A times first term, then the second term AR, then the third term AR square, and then the fourth term AR cube, and so on till nth term, so AR n minus 1. Is it okay?
Yes.
Because the P is the product of the n terms. So now, if we add the powers, this is 1, because it is in multiplication, so we can add the powers, so that is 1, 1, 1 all. So it will be A raised to the power n. Is it okay?
Yes.
Times, now if you see the power of the R, so this is 1, 2, 3, so you can write 1 plus 2 plus 3 and so on n minus 1. Now this will be A raised to the power n, and if you see R, this is the sum of the n terms, and we know that the sum of the n terms is n by 2. N is the number of terms, so we have n minus 1. Sum of the n terms is given by n by 2, first term plus last term. So here the number of term is n minus 1, and the first term is 1 and the last term is n minus. Because this is in AP, so we can apply the AP formula for this sum. So now this is going to be A raised to the power n, R raised to the power n times n minus 1 upon 2. Got it?
Yes.
Now this can be written like AR n minus 1 by 2 and whole n. Can we say that?
Yes.
Yeah.
Okay, sir.
Now, if you see this term, this one, can we write it like, we have to get P square, so squaring both the sides, so we can write P square, and this will be AR n minus 1 over 2, and this is n and 2 here. Is it okay?
Yes.
On squaring both the sides, so now this will be P square, this will be, now this is a power 2n, so it goes to both of them, so it is A raised to the power 2n times R raised to the power n minus 1 upon 2 times 2n. Is it fine?
Yes.
Now this 2 and 2 got cancelled, so we can write A raised to the power 2n times R raised to the power n minus 1 times n. So this is going to be A times, see, A time, it is A square, and we can write R n minus 1, and this is n. Is it fine?
Yes.
Now can we write it like A square is A times A R raised to the power n minus 1, and this is n. Fine?
Yes, sir.
So this will be a as it is, and this is the nth term, and they have given that the nth term is b, so we can put b here, and this is raised to the power n. So we proved p square equals to ab raised to the power n. Fine?
Yes.
Done. Understand, a little bit of calculation is there, but it's fine. Question was the
Okay, sir.
first term and the nth term was given, so first term is a, nth term is b. This
Okay,
data
sir.
it was given, and then they have told us to find the product of the terms, but they want p square. So for finding the product, what we did, we simply multiplied all of them, and then we saw that the power of the a will be n because n number of terms, and the power of the r will be r plus till n minus 1. Then we applied
Yes.
the formula for the sum of the ap because 1 2 3 in ap, and then just simplifying it and then solved it. Okay,
Okay, sir.
make a note of
Yes,
it.
sir.
Yeah.
Is